All right, so today we're going to summarize section 2.3, derivative of a constant function. And there's three basic principles, and then we're going to put them all together. So the first principle we're going to have today is the derivative of a constant function. The second one we're going to have is we're going to take the first rule, and we're going to apply it as a multiplier to another function. The third item is a power function rule, and so we will talk about the power rule. And then the fourth step is going to be to put those three items together. And so we're going to need to know when to use them and when not to use them. Okay? So the first one is the derivative of a constant function. And so as a short, this is y equals k. We should be thinking of a horizontal line. And that makes this super easy because remember that derivative is equal to the word slope from Algebra 1. And so what we're really asking for when we say derivative of a constant function, we're really asking for the slope of a horizontal line. What's the slope of a horizontal line? Correct. Okay. So in terms of applying that principle, we'll do one quick example. We'll say y equals 3 or f of x equals 3. And we're going to apply the definition, the limit as h goes to 0 of the derivative. This is the definition. And so you can see here, there's no place to plug in x or x plus h. So f of x plus h is equal to the same as f of x, which means that function value is never changing. And therefore, the top is 0, and we're never going to get a change. So there's no vertical change on those. And so we always just say that the slope of a horizontal line is equivalent to the derivative of a constant function. Okay? So super easy. Derivative of any constant. If this is my original, then y prime is 0. Okay? Derivative of a constant. The second thing we're going to do is we're going to take the derivative of a constant times a function. Okay? So let's stay with that same example, and we're going to use 3 times x. You wouldn't normally see it that way. You would normally see it, f of x is equal to 3x, and you'd say, oh, that's 3x, okay? But what I'm going to say is, hey, I'm going to pull the 3 out, and then I really just have this function x, so to speak, right? So f of x, so in my head, I'm going to say that's my function. And so 3 of those functions is really what I'm going to look at. So I want to take the derivative here, and then I'm going to multiply it by 3. That's really what we're doing. So if I go and I use my definition again, and remember, I want to use this. So x plus h minus x all over h. That's the limit. The limit of x is, so if I took this and I said, hey, not the limit of x. I'm talking about the limit as the function of the function is equal to 1. Okay. Well, if 3f of x is really like saying 3x, then I should be able to say, if it's true, if what I'm telling you is true, I should be able to get this, and I should get 3. So let's do it the long way and say, okay, I'm going to use the function 3x. And so I want to find f prime of x. And now definition is here. And so I'm going to write out every step just so that you can see it for now. Gone. I get 3. Okay? So, and this is true for everything. Now, I don't want to do a larger function right now. I'm going to do that after I do power rule. But what I would tell you is this. The rule is anytime you're given k times some stuff. It doesn't matter what the stuff is. It could be x to the bazillion. Who cares? This k factor here can just be brought down so that when you do f prime of x, whatever was here, whatever was in there, you're going to bring down, okay? And again, right now I'm saying x. I just proved it with 3x, but this x junk, I'm going to show you how it works with even 3x squared or a bigger, larger polynomial, okay? So keep in mind, all I'm saying right now is a constant times a derivative means you bring that constant down and then you take the derivative of everything else, okay? This is great because this is going to eliminate having to use the definition of derivative. You guys are going to be so happy. Okay, so in order to do this, there's a rule. And anytime we raise something to a power, it's to the nth power, okay? And so I'm going to give you the rule, and then I'm going to apply it. And I'm going to remind you that we've done this several times the long way, okay? So if I want to take the derivative of f with respect to x, I'm going to take this and I'm going to pull it down front. And then up here, I'm going to subtract 1 from whatever the power was, okay, from whatever the power was. And this is going to be true all the time. So I'm going to do about 6 examples that we've done in class. So let's say I have my favorite calc function. So f prime of x, the derivative of f with respect to x, means I want to bring the 2 down. Now, in my head, I'm writing it for you for the first few times. What's 2 minus 1? 1. We don't normally write the 1, so we say 2 to the x. Or, my bad, scratch that, 2x. Ooh, bad Miss Collins. Okay, so that's an example. Let's do another one that we've done. You've done this one several times. F of x is equal to x cubed. So f prime of x, the derivative of f with respect to x, bring down the power, subtract 1 from the original power, and you get 3x squared. Check your notes. I guarantee you, you've done this. We've done this one, the square root of x. Now, this one's a little harder, and the reason is we don't normally see this written like this, okay? But a square root sign is really a 1/2 power. Remember, there's a little 2 and a little 1, and that's how we write it. So now, if I want to take f prime of x, so now I'm going to bring the 1/2 down, take the x, subtract 1 from the original power, and I know we love fractions, to the negative 1/2. Now, let's go back to Algebra 1. Here we are, Algebra 1. Laws of exponents. When I have an exponent and it is on top and it is negative, I need to move it to the correct bottom. And just so that we're clear, standard notation says we would write this. I would strongly encourage you to go back and look at your notes. You will see, in fact, you did this one and you have actually done this one twice in your notes and in your practice in class. Okay, so that's how power rule works, okay? Power rule says, I'm going to scroll back up here, it says if you have any function in terms of x to the nth power, I mean, that could be a t to the nth power, it could be anything, it doesn't have to be an x. What you're going to do is take that power, move it down front, and take x to the n minus 1 power. That is, in fact, the derivative, and your book will refer to this, we will refer to this as the power rule, okay? It is the power rule, and it's how we take 90% of the derivatives for the first few weeks, okay? Now what I want to do is I want to take the idea of the constant together with power rule, and we're going to use sum and difference functions. So we're only going to kick it up a notch here, okay? We're just going to kick it up 1 notch, and we're going to say, hey, what if you had this function? Okay? So each of these pieces can be done separate, keeping in mind that the sign between them stays the same. You don't change the sum or difference. It stays. So if I want to take the derivative of f with respect to x, so for this one, I want to use power rule. And that says I would bring down the 2. The x comes along, and 2 minus 1 is 1, but I don't write it, so 2x. We just did this one. Remember, this is really x to the 1/2, so it becomes 1/2 x to the negative 1/2. We just did it. That's the answer, okay? So the power rule combined with the constant derivative and derivative of a constant times a function is now going to be what we use to do derivatives of polynomials. So now we can put two things together or more. So I could say, let's do a difficult one. 4x cubed minus 3x squared plus 12x minus 17. Okay, so I'm going to show you how these rules combine. So right here, we're going to have k times some function. And then in order to do the sum function, we're going to need our power rule. Okay, again, same thing. We have a power function and we have a constant. We have a constant and power function. And here we have a constant. Okay, so let's do this one first. What's the derivative of negative 17? 0. Okay, so now let's take this one baby steps. The 4 is going to stay out front. Now we're going to take the derivative of x cubed. The derivative of x cubed is going to lead us to 3x squared. Remember, the 3 comes out front. X, what's 3 minus 1? And that's going to get us our 3x squared. Minus, the 3 comes out front. What was the derivative of x squared? Was the first example? Good. 2x. And now for the last example. Remember the very first example I did? Constant times the derivative. We can also use power rule here. 12 is my constant. What's the power that's written right here? When it is not written, remember, it's the number 1 times x to the what power? What's 1 minus 1? Good, it's 0. Anything to the 0 power is just a 1. So this is really 12 times 1. And this was a minus sign, so let me make sure that says minus 0. So we can get rid of that. And now let's simplify. Now we want to finish it. So 4 times 3, 3 times 2, plus 12. And that is the derivative of f with respect to x. Okay? Some of you are not going to need to see this written out every single time. You won't have to do this, and you'll start to get it much faster, but I want to do one more example. Let's say you had 6x to the negative 4/3 plus 1/2 to x to the 6th. This is not written in any specific order. Plus 3 times x to the 12th. That's good enough. Okay, so it looks a little uglier, and again, it's the same thing. So this is a constant. Pull it down. Now let's take the derivative of f with respect to x. So now I just want to look at this little piece right here. I bring down the power. I take x still. And now I want to do negative 4/3 minus 3/3. And remember, when we're doing fractions, we start to freak out. Do not freak out. It's not that big a deal. But the most important thing is that we remember the common denominators. So negative 4 minus 3 makes it negative 7/3. And then we're done with that one. Plus 1/2, the constant stays. Now we want to just look at that piece. Okay, I'm sure you're already telling yourself 6x to the 5th. Well done. Now, plus 3, the constant still comes down. The derivative of x to the 12th, already you have it. Look at, you guys are like, hurry up, Miss Collins, shut up. I know. But just so we're clear, so now I want to reduce, so I get 2, so negative 8, and I'm writing it in standard notation. We don't use negative exponents, so this is x to the 7/3 on bottom, plus 3x to the 5th, plus 48x to the 11th. Oh, Miss Collins, you silly goose. Okay, I'm changing it right now, 36. That's an error. Okay, my bad. Okay, so those are the 3 big ideas. You have constants, derivatives of constants, you have the power rule, and then you have combining the power rule with the constant rule, okay? So section 2.3 problem set, I'll be giving you tomorrow in class. This should be enough to get you through the quick check on the other set of 2.3 notes. All right, good luck.